Now, in order for you to be able to discover what happens in this new vertex form, I wanted to show you what I need you to do on the next couple of slides. So you always start with your parent function. So I'm always going to have the parent function points plotted. Remember from the previous video, it's at 0, 0, 1, 1, and 2, 4. I also reflect these, and they're going to then look like this at negative 1, 1, and negative 2, 4. So you always start here. And what you're going to do is you are going to try to track what happened to these points on your new graph, which is going to be this one here. Now let me show you how to do it in your calculator. Boop. So if I was doing this one, I would go to the y equals first to type into, or my equation into the calculator. So y equals is up here, and I will type in x squared. To get the x, you use the button right here beside alpha. So click x, and then you square it. That is the parent function. And if I graph it, it looks just like these points right here. There's the 0, 0. If you look really closely, there's 1, 1. And here is 2, and then 4. Now, it is tough to see. They do not have the points plotted. If you wanted to see the points, you would go to second table, and you could see 0, 0, 1, 1, 2, 4. You don't have to do that, though. Now, on the same coordinate plane, so you're going to go to the second function, you're going to type this in now. So x squared, and then plus 5. Now, each time I have a number with the parent function, or I change the format of how it looks, you should discover something that that number is going to do to these points that are written in red over here. So when I go to click the graph button, I should now see two parabolas. The first one that I see drawn is the parent function, and the second one is going to be whatever this is. And you should be able to determine what this plus 5 does to change the parent function. So if we click graph, there's the parent, and here is the new one that's drawn. So you're going to try to track these points that were on the parent function first to see what happened to them. You might already have a conclusion based off of what you see here. It looks like this point now is at 0, 5. And if I go one block over, which should have been at 1, right, for the parent function, one block over is now up at 6. And then 2 blocks over should be at 4, but 2 blocks over on here is actually at 8. Sorry, 9. So what actually happened here? If you're having a hard time, you can go into the table and you can look at your table. Now what you're going to see is this. Ready? Here's the original first function you typed in. So this is always your parent function here. Here are the new y values for the same x's. So the y value looks like these now, from 0 to 5, from 1 to 6, from 4 to 9. So if you're having a hard time seeing the points, then you can go ahead and look in your table. If the calculator here is a little bit too small, then you can certainly do this in Desmos. If you go to Desmos and then you go to the calculator, you can type this in there too. Y equals x, and then use your caret to make a square. There's the parent function. I would always zoom out so that each of these blocks count as 1. So I'm going to go ahead and zoom out. Once you see this 5 here, that means that each of these blocks is counting as 1. I can see 0, 1. I can go to 1 and click on my graph. And right there, oops, it's at 1, 1. And at 2, I can see that it's at 4. It's a little bit bigger. Okay, then I would go to the second space here and type in my other one. Remember, it was x to the second plus 5. So we can see that new point there. When we go one block over, I can click on that. And it shows me it's at 6. And go over here 2 blocks, and I see that it is on, looks like 9. I can't quite get to 2. There it is, 2, 9. So I can compare, and I can maybe even graph those points. See, if I went back to my graph, I could then say, okay, well, the points are now actually here. So this one went to 0, 5. This one is up here at 6. This one went up to 9. And then I can reflect them across. What happened in this graph? So you're going to make a conclusion based off of what you see here. Now, I'm going to change it up each time. So now this looks totally different. So in your calculator, you're going to keep your parent function in the top so you can make the comparison. And you're also going to remember that you should be plotting those parent function points on a graph that you have available to you. So there's the parent functions, and that's this guy here. When I go to graph the other one, which I'm going to go ahead and use blue, again, in my calculator, I'm just going to delete this one. So I'm going to keep the parent function in there. I'm going to clear out this guy, and I'm going to type in the new one. So I would type in now a parenthesis x plus 5 and then square it. Now notice that there's something different about how this looks. Of course, we have parentheses now, and the 5 is on the inside. This is going to do something different to your parent function. Let's take a look. So there's the parent, and here is the new one now. The parent function, or whatever you have first in this right here, is going to be the one that graphs first. And then here is going to be the one that graphs second. And we can see that here is the new parabola. Okay? So it will be harder for you to determine in the table what happens. If you want to, you can go to desmos, and you can do the same thing in here. So leave your parent function in, and you're going to type instead parentheses x plus 5 square. And we can see the blue, and then we can go ahead and notice here is negative 5, 0 now. One block over, which should be at 1, 1, is now at negative 4 and then 1. So it looks like it's still at 1, but something happened to make the x change. And then 2 blocks over gives me 4. Well, I'm noticing, yeah, right there. If I go 2 blocks over, I should be at 4 on the parent function, which I am, but it's totally moved over here. So what do you think that plus 5 on the inside of the parenthesis does? So this is what you're trying to figure out. What did the plus 5 inside do? And on the last example, what did the plus 5 on the outside do? What did this do whenever it wasn't inside of parentheses? It's totally different. As you can see, that was a different graph than what we just got. There's more for you to discover, so please make sure you're trying to decide what happens. And by the end of your Nearpod, you should be able to figure out what these numbers are doing to your function. Good luck.